So the first week of our course this summer has 4 different topics that you're going to work on. Topics 1, 2, 3, and 3 stars. So that's arithmetic, that includes the arithmetic of fractions. PEMDAS, that's how to use the order of operations to evaluate expressions. How to solve simple linear equations and inequalities. And then topic 3 star, this is just for the 095 students. This is how to solve compounding inequalities as well as inequalities involving absolute value. So there's a good chunk of stuff that you're going to have about the next 8 days to make progress on. Week number 2, so that's the week that follows, so from next Friday to the following Thursday, so that's between next Friday and our next in-person meeting on Thursday the 8th. There you'll have, so our second week of the semester will be topic 4 and topic 5, so linear graphs and linear systems. So the first 4 topics are part of the first week, and then the next 2 topics are part of the week that follows. So I want to just take the next hour or so to get a flyover of each of these to give you a sneak preview of what they are. We can talk a little bit about, what are your sort of general questions about how to approach them. And then you'll get into them in some more detail when you do the reading assignments, when you contribute videos, when you do some web work practice problems, when you download and complete quizzes and so forth over the next couple weeks as we interact online. So let's take our first moment to talk about arithmetic and the order of operations. So here's a problem that asks you to do some arithmetic with whole numbers and fractions, and there's also a mixture of different mixture of different operations inside it. I have some subtraction going on here. I have multiplication going on right there. I also have an exponent that's up there at the top. So the question is, how do I approach simplifying an expression like this? What should I think about first? What should my strategy be? So when we think about the order of operations, we usually think of that acronym, PEMDAS, in which the first letter P stands for parentheses. So the first thing I should think is there any opportunity for me to look inside these parentheses and to simplify what's inside the parentheses? Can I simplify the fraction 3 over 4 any further? I can't make the fraction 3/4 any simpler because 3 and 4 have no factors in common that I could factor out and divide by to reduce the fraction. Right? So what's inside these parentheses is as simple as possible. So that means that we are done with the P part in PEMDAS. And so our next priority then is E, which stands for exponents. So for that, now I remember, oh yeah, there is an exponent of 2 attached to this fraction, 3/4. So let's work on that. So how do I accomplish the operation of raising 3/4 to the power 2? How do we think about that? So one of the most important things to remember is that squaring, no matter where we see it, no matter what context, always means multiplying something by itself. So instead of thinking of this as an exponent question, I'm going to think of it as a multiplication question. 3/4 times 3/4. Which now means that we should think about how to multiply one fraction by another. How do you multiply 2 fractions? These are going to be skills you're going to dust off as we get into the arithmetic chapter. But when you multiply 2 fractions, they multiply straight across the numerator and straight across the denominator. So the numerator of the product is 3 times 3, that's 9. The denominator of the product, 4 times 4, is 16. So the result of squaring 3/4 is that I get 9 over 16. And now the exponents part in my PEMDAS story is all set, because now my expression will have no exponents left over. Let's take a look to remember what else was there. So I still have subtraction going on, and I also have multiplication going on. According to PEMDAS, which of those 2 should I do first? Yeah, the multiplication, the M in the PEMDAS. So I should worry about this multiplication. So I'm going to just hide the subtraction here for a second so we can focus on doing this multiplication. Now that we know that 3/4 squared is 9/16, now we understand that what we have to do is multiply 1/3 by 9/16. So it's another fraction multiplication, which how do you multiply fractions? Straight across. 1 times 9, so the numerator of that product is 9. 3 times 16, so the denominator of that product is 48. So I have 9 over 48. for that product. Before I go any further, let's ask, is 9 over 48 in its simplest form? Or can I make that fraction simpler before we go back to do the rest of the arithmetic? So the key to whether a fraction is in its lowest terms or not is really the opposite of the multiplication process that we did. Remember, we multiplied fractions, we multiplied them straight across. The question here is, can I break apart this fraction in a way that will give me a common factor in the numerator and denominator? So, for example, we know that 6 can be written as 2 times 3. We also know that 16 can be written as 2 times 8. Right? So I think no one would disagree that I could rewrite the fraction in this way. 6 is 2 times 3, 16 is 2 times 8. But remember, multiplying straight across is the same as multiplying two fractions. So I could instead see this as 2 over 2 times 3 over 8. But what is 2 over 2? Another name for 1. And what happens to any quantity at all when we multiply it by 1? It's unchanged. So reducing a fraction into its lowest terms is really a process of undoing that straight across multiplication, if it's possible. Right? So looking back at what we just did, if we wanted to simplify 6 over 16, we first had to know that both 6 and 18 could be rewritten in a way that exposed that 6 and 16 each have a factor 2 that makes them up. Right? And the fact that those two were the same is what made it so that when we undid the multiplication straight across and interpreted it instead as the multiplication of two fractions, that left me with a 2 over 2 out in the front, which was another name for 1, which is an invisible multiplication. So the fact that 6 and 16 both had a common factor of 2 is what made this work, is what made us able to reduce this into lower terms by essentially dividing the numerator and the denominator by 2. That's another way to read the process that we just did. Divide by 2, divide by 2. But now, 3 and 8 cannot be factored in a way that shows that they have anything in common other than 1. And taking a 1 out isn't going to make those numbers any smaller, right? Because taking a 1 out is an invisible operation. So now 3/8 is our lowest terms. So come back to 9 over 48 for a second. Is there any number which both goes evenly into 9 and evenly into 48 that's bigger than 1? Yeah, 3. So it was a little harder to spot in this example because it's easier to spot when a number is divisible by 2, just when it's even, when its one's digit is an even digit, than it is to spot when something's divisible by 3. But sure enough, both 9 and 48 are divisible by 3, which means when I undo this multiplication, I get a 3 over 3, which turns into a 1, which turns invisible. And I can rewrite 9 over 48 as 3 over 16 instead. And I'm choosing to do that now. I could have waited until the very end of the problem to do that, but I'm going to do it now just to make the next step a little bit easier. We can reduce fractions into their lowest terms at any point in our process. It doesn't matter whether we wait, but if we wait, sometimes we have harder work to do in the meantime. So I prefer to think of the result of this multiplication here as 3 over 16. And then our multiplication is done. So our last step, and don't underestimate this step either, our last step is going to be, now we have to subtract. We did our multiplication and division. Now the last thing we have to do is 6 minus 3/16. So now we have to reckon with how to, so how am I going to subtract 6 minus 3/16? Unlike multiplication, we don't have a convenient sort of straight across algorithm or anything nice that we can do. What do we have to do in order to subtract two fractions? Before we can subtract two fractions, we should see them first as both fractions. Because here I have a whole number 6. Before I can do anything with this, I should see the number 6 as a fraction. So what's a way to make 6 into a fraction? I need to give it a denominator of some sort. What denominator can I give it? 1, right. So can't do much with a whole number and a fraction until we put them both into fraction land. So I'm going to make that 6 into a 6 over 1. And now I'm going to follow Mark's suggestion, which is before we add or subtract fractions, they need to have a common denominator. That's not true with multiplication and division, but it is true with addition and subtraction, which makes addition and subtraction harder in general with fractions. It gives us more work to do. So I need to find a denominator that both can be a multiple of 1 and also a multiple of 16. What's a number which is both a multiple of 1 and a multiple of 16 that I can use for a common denominator? Yeah, 16. Again, one of the ways we can do this is always just to multiply the two denominators that we started with together. That's sort of the naive route, and it will always work. Just sometimes it'll give you a little bit bigger numbers in the meantime than other ways of looking for a least common multiple might. But I like to do it this way because this is kind of it's almost a no-brainer. Just multiply the denominators together, and that's our new candidate for a common denominator. Then the question is, if I change the denominator of a fraction, what do I have to do to the numerator? Now, we didn't change the denominator for the second fraction, right? The 3/16, and so there I don't have to do anything. I'll just carry that 3 straight across. But for my first fraction, 6 over 1, I've changed the denominator from 1 to 16. So what do I have to do to the numerator? Yeah, I have to multiply. I have to multiply in the numerator by the same thing that I multiplied by in the denominator. Why? Because doing so is going to give us, if we multiply across, a fraction which cancels out to 1. Right? So we haven't changed the value of this rational number by doing this. So whatever I multiplied the denominator by, I need to also multiply the numerator by. What did I multiply 1 by in order to get 16? 1 times 16. Therefore, I need to also multiply the numerator by 16. 6 times 16 is 96, I hope. I think that's right. I'm running without a calculator, which I recommend you do as well, just at least for the first unit. And now I have common denominator of 16 for both of my fractions. And since both my fractions have that denominator, how do I then subtract them? Now that we're ready to do so, how does that subtraction actually occur? First of all, what's the denominator on my difference going to be? 16. So you keep the denominator. Never change it. Don't add denominators or subtract denominators. Just keep them. And the subtraction, per se, happens up here. 96 minus 3, 93. Now, the only thing that might remain to do in this problem is reduce the fraction 93 over 16 into lower terms if it's possible. Is it possible? Do 93 and 16 have any factors in common that we can cancel? I don't think they do, because 16 has only factors of 2, 4, and 8 inside of it, right? If I look at a factor tree for it, it's got only 2's at the end. 93, meanwhile, is 3 times 31, but 31 doesn't have any factors, any interesting factors. Neither does 3. Those are both prime. And so there's no factor in the numerator and denominator that's common, so I can't do any canceling, so I've got to be done. Also, for the purposes of our course, you can feel free to leave a number like 93 over 16 as an improper fraction. Leave it as it is. Don't feel the need to reduce it down to, oh gosh, what would it be? 5 and 13/16, which is how it might look on like a carpenter's diagram or something like that. I'm fine with improper fractions. Web work is fine with improper fractions, so don't feel pressured to do the mixed number conversion on that. This video is an example of one of the videos that I've used as a part of this course in the past. You are welcome, as part of your video contribution assignments, to pull from these if you find these videos especially helpful. They're intended to be kept very short, so all of these videos are between like 3 and 6 minutes or so, and just to explain one of the main sort of goal topic areas for the course in kind of a step-by-step, break it down but not explain it in long detail like we did now, just explain it in a way that will help you to refresh your memory. So you'll have a link to these videos in Blackboard too.